Let's start our discussion of cloud computing with a picture of what it's really like. So this image shows a section of a Google data center. These shelving units are called racks, and each of these objects that you can see on the rack is a server. Generally speaking, racks are measured in inches because the US started this, and each of these servers looks to be 2 U's, where a U is 1 3/4 inches high. As you can see, there's a lot of servers there, and these go to make up just components of the cloud. So what is the cloud in terms of definitions? So the definition here, which is quite old but still accurate, is using virtualized IT resources housed outside your own data center that are shared, simple to use, paid for via subscription and accessed over the web. Another definition from Wikipedia says pretty much the same thing, except it mentions that services are offered in a metered way and accessed over the internet. So why call it cloud computing? Well, the origin of the term goes back to when people wanted to show some connections between different kind of resources and they didn't want to specify how they were used. They would just draw a cloud shape and put internet. But behind that internet, what we could see here on the left is we have web servers, we have application servers, we have database machines, we have storage, whole collections of compute type resources, including load balancing, where a load balancer is software and hardware which will look at the incoming network requests, and if it thinks that there is more load than can be coped with one server, will swap to a different server. So quite a lot of infrastructure going on there underneath that cloud. So why care about cloud computing? Well, this slide is actually quite recent, but I had a previous one to this which estimated from 2012 to 17 that in 2017 there'd be about a $200 billion spend. And as you can see here, from 2016 it had already reached a $200 billion annual spend, with estimates for last year of being $500 billion. So that causes a lot of commercial interest. Why? Well, there's a big shift here from capital expenditure to operational expenditure. What this means is that in the past, if you had a large IT project, before you could do anything, you had to buy equipment. That's capital expenditure. So you might actually end up spending thousands, hundreds of thousands of pounds buying servers, buying computing capability and licenses and so on for staff to use. You build an application and prototype and it doesn't go anywhere. So you've got a large expenditure with no necessary result. Operational expenditure refers to the idea that you'll get revenue coming in and you can pay out a much lower amount on a monthly or less basis. So you're paying per use. This means there are much lower barriers if you want to start a business. If you've got some IT computing service you want to try out, you don't need to persuade investors to spend a large amount up front. You can put that expenditure on the cloud, and if things start to take off, then it's very easy to expand. So it can be much cheaper in the long run. Cloud services also have economies of scale. So what we saw in that first slide is there were hundreds of servers, possibly even 1,000 servers, I didn't count them. And the point is, when you're buying that much equipment, you get a huge discount from suppliers. So someone like Google or Microsoft are paying a lot less for a server than you would pay. And in fact, someone made the point that when you go along to the manufacturers and say you're going to buy 5,000 or 6,000 servers, they will actually design them for you. So you don't just get cheaper, they get things which are particularly made to their specifications. And another advantage is geography, which we'll talk about more in a moment. So a major advantage to cloud is it's agile. That means you don't need to provision, order, buy new hardware. This in the past has been a huge issue. You want to buy some collection of servers. It's not like going to buy a laptop. You have to contact a supplier. The thing has to be built to your specification, delivered, and not only that, if it's new equipment, you're going to have to get air conditioning installed, all those kinds of things, which means actually the provisioning and supply of hardware is a time-intensive and demanding process. Whereas if you're using cloud, you just need a credit card, as we'll see. And pretty much 10-15 minutes later, you'll have your web server or whatever it is in the cloud. You also don't need to be concerned about security, in that physical security, logical security will be provided by the cloud supplier. Whereas if you've got your own equipment, it's a valuable asset. It is possibly subject to theft and loss and so on. So with cloud, there aren't necessarily any upfront costs. In terms of reliability, this is quite an old slide, but it shows some of the different availability zones that Amazon have. Both Amazon and Azure use almost identical terminology. They split the world up into regions, and within each region there will be multiple data centers. Each of these data centers are specifically designed to be a certain distance apart. So I think it's at least 30 miles. So you may host a service which is offered from one region, one availability zone, and within that availability zone it's actually running on machines which are at least 30 miles apart. So you have geographical replication and safety from immediate natural disasters. Another issue is, for example, you might be a small company in the northeast of England. You could host your service on Amazon in the States, get immediate access to that market. So there's no delay in for customers in that region getting access to your service.